Okay, guys. So Earth systems. This is where our next subject is, and Earth systems is an idea about how the Earth is actually a whole system, and a system is basically something that works together in a lot of different moving parts, right? And so Earth systems are composed of basically four basic systems. You have what we call the atmosphere, the geosphere, the hydrosphere, and the biosphere. Now, this class is based off of Earth systems, so we're going to be focusing mostly on the geosphere. But we're going to be talking about how the geosphere interacts with all these other spheres as well. And there are another class here on campus that we actually do that relates to more to the biosphere, which is we call the environmental science, right? And so, but we're going to be focusing more on geospheres because it's the Earth science class. And so, the different spheres that we're talking about can be what we call, or different systems, I should say, are either what we call a closed system or an open system. Open systems tend to have energy going in and out, but also mass going in and out. Whereas a closed system is a system that has energy going in, energy going out, but no mass difference. It could also be the other way, where we have mass going in and out, but no energy transfer. Okay, so the system here that best represents our natural world, okay, would probably be an open system. Now, depending on how you looked at it. Now, if you think about like a stream or something like that, it has energy going into that stream, has mass going out of that stream, and mass coming in that stream. So that would be what we'd consider an open system, right? Whereas if you look at the whole Earth as itself, where there's energy coming in all the time, UV energy and things like that, but there's not really much mass transfer. So if you think of it that way, then the whole Earth in itself would be what we call a closed system. But once again, most systems here on Earth are what we call open. And so in our system, in what we call the Earth sphere, we're going to kind of focus, like I said, more on the geosphere, which is really come from the top of the Earth's crust. Excuse me. From the top of the Earth's crust, or our surface, all the way down to the core of the Earth. Okay, this is the largest of our Earth spheres, and there's different cycles within it that we're going to kind of be focusing on quite a bit. For example, the rock cycle, which is talking about how rocks change over time, going from a magma to more molten rock to something that's cooled off to form what we call an igneous rock. That igneous rock can then be eroded. And then that sediments can actually be solidified together to form what we call a sedimentary rock. That sedimentary rock can go underneath heat and pressure to form a metamorphic rock, and so forth. Right? So that's what we would consider what we call the rock cycle, and we'll get back to that. But that's where we're going to be spending most of our time here in this class. Okay. Now the hydrosphere, or a special type of the hydrosphere, which we call a cryosphere, which is the frozen part of the hydrosphere, also can interact with our planet. Okay, so this water moving down a valley or something like that is going to erode the valley and cause a stream, right? And also that water is going to flow through the rock to form what we call groundwater, where we can get some of our drinking water. Or maybe the ice is actually going to flow down in the form of a glacier, carve out a mountainside, and therefore that's an interaction of the cryosphere with the geosphere. All of these are different interactions within the system. Okay? The atmosphere is also one that we're going to be discussing a little bit. The atmosphere is that thin kind of layer, above our geosphere, right? That has where most of our weather comes from, and that weather phenomenon can interact with our geosphere. Think of like a hurricane and how a hurricane waves can actually interact with our coasts to actually form floods or erosion there on the coastlines. Okay, those are just some examples. Okay, well, the biosphere includes all of life, humans, bacteria, plants, any form of life out there, and they can interact with the geosphere as well. For example, roots can actually go down to the ground, break apart rocks. Humans can actually dig and move material around, so can animals burrow in the ground. So we do change the geosphere around us all the time. Okay. Now there is some that would actually argue that there's another sphere, which would be or be a special type of the biosphere, which is what we call anthroposphere, which is human interactions with the geosphere itself, okay, or within this whole system, because we alter our system by taking the resources within that system and impacting climate, like in climate change, global warming kind of issues. Okay, we can actually contaminate the water supply and change the water supplies, redirect them into different directions by damming them. These are all parts of what humans do in interaction with that within that sphere. So some would actually include that, and I'm one of those who'd like to include the anthroposphere as another kind of sphere, special sphere, based off of the biosphere. Okay, so but we're going to be focusing, like I said, on the geosphere, into what we call geological systems. So we're going to be focusing the first part of the semester on the rock cycle, or this part of the geosphere, and then we'll actually kind of go into the hydrosphere and how the hydrosphere interacts with the geosphere, and then also the atmosphere with the geosphere. So those are the three main ones that we're going to be going to. We'll talk about the biosphere periodically, but we're going to be really focusing on those three main spheres: the hydrosphere, the geosphere, and the atmosphere. Okay, so these spheres all interact with one another. Here's a good example. So in May 18th, 1980, Mount St. Helens erupted. I actually remember this. I lived in Idaho at the time, and I actually remember the ash coming down and in our area. It looked kind of like a snowfall in a sense. Okay, but anyways, the ash erupted up into the air, and that ash actually impacts both the geosphere, the atmosphere, and the hydrosphere. Okay, and the biosphere in a sense as well. So, for example, okay, the volcano which is part of the geosphere, interacts with the atmosphere and the hydrosphere and the biosphere in different ways. So, for example, the volcano can release a large amount of particulate matter or ash into the atmosphere. These particles serve as nuclei for the formation of water droplets or rain, and that rainfall will increase following the eruption, which will stimulate plant growth, right? However, that same particulate matter that is in the air falls out and can smother the plants, which will interact with the biosphere. But as that ash breaks down, it releases nutrients into the soil, which will enrich the soil, which is the geosphere, and then stimulate more plant growth, right? Biosphere. So it has a negative impact or positive impact on the environment, okay, depending on how you interpret that. Now, I say that because what we call negative feedbacks and positive feedbacks are not necessarily a good thing or a bad thing. It's just what we call a stabilizing thing or a destabilizing thing. Negative feedbacks are what we call stabilizing impacts, whereas positive feedbacks are what we call destabilizing impacts. Here's an example. Okay, so if it snows, that snow cover will actually go on the ground, and then light will hit that snow cover and then reflect back into space, causing it to be colder, which then causes there to be, in some cases, more snow, which then will cause it to be colder. So this is what we call a destabilizing impact, okay, or a positive feedback, where it's getting colder and colder and colder because of the white snow. Okay, a negative feedback might be something like this, where we might have erosion on a slope. Okay, and that erosion in that slope, that sediment will then go into our stream, okay, bed, which will slow down channel erosion because the water will slow down. With the slope, it slows down, okay, the channel erosion, then it will actually increase the angle of the slope. Well, if it increases the angle of the slope, it then will increase the velocity of the river, which then will cause more slope erosion, and therefore it goes right back to normal. Okay, so that's a stabilizing impact. Whereas here's another one where you have slope erosion, which means that it decreases the infiltration capacity of something, which then will add to the surface runoff, which will cause more slope erosion. Okay, and so it's the difference between what we call negative feedback, which is a stabilizing effect, and then a positive feedback, which is a destabilizing effect. Okay, okay. So that's Earth systems. I think that we're going to stop there for Earth systems, and then we're going to start into our next subject after that, where we're going to start talking about the formation of our planet, going into chapter 1. So that first section, the mini lecture 1 and 2 that we just did, are really the subjects regarding the prelude material, okay, that you had the reading from. I think it's the first 20 pages of the text. Whereas this second material is going to be that second material within the text, or the first chapter, if I remember right. Okay, so we'll see you in the next mini lecture.